Hello students, as I said that we will learn about how to find the solution of algebraic and transcendental equation. Now I can say one thing here. Suppose if you have an equation like x is cube minus 3x plus 2 is equals to 0. So all of you can find the solution for this equation. I hope all of you can do it. But if I give you the equation like that, x e to the power x minus 10x is equals to 0, now can you find it the solution? So obviously, till now you people don't know how to find that equation. So today we will learn a method by which we can find solution of both the equation, algebraic, polynomial equation and transcendental equation. So suppose we have an equation f of x equals to 0. Now we will find the root of that equation. So in this section, the first method which is included in our syllabus, that is bisection method. Now what is bisection method? So let's learn it by geometrically, and after that we will learn it how to do it. Okay. So see, now you have a equation f of x equals to 0. So we can draw the graph y is equals to f of x. This is my y is equals to f of x. Now already we know that an equation f of x equals to 0 that has a root. So that means it obviously intersects the x-axis. This is my root. Now in this picture you can see whenever a graph intersect the x-axis, so that means it may have goes from the downside to upward side, or maybe it goes to the upward side to downward side. Obviously, the y is equals to f of x, this graph look like this from downside to upside, or maybe upside to downside. Now, let us assume this is my graph. Now, here you can see also one thing. Suppose this is my interval x equals to a and x equals to b. Okay, now what is the functional value here? So that is my f of a. This is my functional value, and this is my functional value f of b. Now, intersect means it goes from this side to this side. Now, this side functional value is obviously negative, and this side functional value is obviously positive. So now f of a into f of b is obviously less than 0. Okay, so that means we can say that for a function or for a equation f of x equals to 0 has a root in the interval a to b if and only if f of a into f of b less than 0. Okay. Now, when we got that interval, okay, we have got that interval a and b. After that, what we will do? We will divide this interval a plus b by 2. That means C is a point C, which is actually a plus b by 2. Okay. Whenever we got the C, so that means we can find the functional value C. Now we know that any function has a root if and only has a root in the interval a comma b if your multiplication of f of a into f of b less than 0. Okay, now we are getting a point C, that is a plus b by 2. So here what you have to do, you have to find the functional value of C, and you have to check is f dash a into f dash c less than 0, or f dash c into f dash b less than 0. any one of them is 0. Okay. So if this is less than 0, then root lies between A to C. Or if this is less than 0, then root lies between C to B. So now here you can see that your interval is decreasing. Now your root of interval is this A to C. But in this picture, your root of interval is A to C. Okay. So by this picture, you are getting your interval is A to C. After that, what we will do? Again, we will divide my interval into two parts. And again, we will check f of A into f of D less than 0 or f of D into f of C less than 0. Now, which one satisfies the condition? Root lies on that interval. So in this picture, here it is maybe your D and this condition is satisfied. So your next root of interval is D to C. You can see next root of interval is D to C. So like this, your root of interval is going to the root. It is converging to the root. Now, where should I stop? In the given question, stopping criteria will be mentioned. Maybe they will ask you to finish up to some fixed iteration, maybe it's 7th, 8th iteration, or maybe they will ask you to find the root correct up to 5 decimal places, if 2 decimal places, like that they will give you the stopping criteria. So using the stopping criteria, you have to calculate it. So what are the methods we will follow? What are the steps we will follow? So first, we will find 2 points, x0. Okay, first we have to find 2 points, x0 and x1, in which f of x0 into f of x1 less than 0. That is my first task. Whenever we can find this f of x0 into f of x1 less than 0, then that means root lies in the interval x0 to x1. This is my first step. After that, we will divide this interval into two parts. x2, what is this? That is actually midpoint, x0, x1 by 2. Okay, you have to find your x2, that is actually here C. Okay, now you have to find the C. Or also you can write it x2. This is your x2. Okay, so whenever you have found the value f of x2, after that you have to check f of x0 into f of x2 less than 0 or f of x2 into f of x1 less than 0. So which one less than 0? Then root lies between this interval. Okay, and this is your desired root of accuracy actually here. Desired degree of accuracy. That means in the first step you are getting x1. In the second step you are getting x2. Like this, in the n step you will get xn. In the n plus 1 step you will get xn plus 1 step. In every steps you have to check that xn minus xn plus 1, that is your less than epsilon or not. This will be given. This epsilon value will be given if your subtraction value less than epsilon. Whenever you will get it, then you stop there and you say the root is your xn. Okay. Or let's solve an example. See, this is your find the root of the equation x cube minus 4x minus 9 equals to 0. And you have to solve it by using bisection method. So what we will do, first, whatever this is given, x cube minus 4x minus 9, that will be considered as a f of x. Okay. Now, after that, we have to find the value f of 0, f of 1, f of 2, f of 3, like that you have to find the values. And after finding the values, I have seen that f of 2 is giving negative value and f of 3 that is giving me positive value. So that means the multiplication of f of 2 and f of 3 will be less than 0. So from here, we can take a decision that our root lies between 2 to 3. Now, my first approximation, that is actually middle point of 2 and 3. So we will denoting as a x1, that is your 1 by 2, 2 plus 3, so 2.5. Now, in this point, I have to check the functional value f of x1, that means f of 2.51, that is actually negative. Okay. So now, here you can see f of 2 is negative. Okay, so we can see f of 2 that is negative, f of 2.5 that is also negative, and f of 3 that is positive. So now if I multiply f of 2 and f of 2.5, that is obviously positive. So this is not the interval. But if we choose 2.5 and 3, and if we can see the multiplication is less than 0, so the root lies between x1 and 3. The x1 means here 2.5 and 3. So for the next we have to go for the second step, for the second approximation. So second approximation is x1 plus 3 by 2. So that is your 2.5. And again here you have to check functional value of f of 2.75. And that you have to check is positive and negative. And again, for this way, you have to proceed. Now, here you can see method correct to 3 decimal places. So that means your root should be correct up to 3 decimal places. Okay. So I told you two type of stopping criteria. Stopping criteria will be 2 type. Okay. First one, fixed iteration, number of iteration fixed hoga, and second one is this one, correct up to some decimal places. Okay. So now see here, if it is in the question, if it is give up to 5th iteration or 6th iteration, so like this, first I have find x1, is after that x2, and similarly we will get x3, x4, and x5. There we will stop. Okay. If it asked us that stopping criteria is up to 5th iteration, so whenever you go to x5, then you stop there and you just say this is your root. But if they ask you correct up to 3 decimal places, okay? So correct up to 3 decimal places means what you have to check, xn minus xn plus 1 less than 0.0.0.1. Okay, correct up to 3 decimal places, matlab up to 3 decimal places, it will give you 0, and after that 1. Okay, or maybe some number it is. Okay, 1 or 2, or it is some maybe real number. Okay, now see, whatever the process that we will do, we can write it in a table. So in table, first column is iteration number. Next, here I have written the negative, means for which value, for which point functional value is negative, and for which point the functional value is positive. And here it is my midpoint, that is xn, and here my f of x. So in the first iteration, what I do, I have seen here, you can see also f of 2 is negative. So that's why we have written here 2. And f of 3 is positive. So that's why we have written here 3. Now, what we will do here, that is my midpoint. So 2 plus 3 by 2. Okay? So this is actually 2 plus 3 by 2. This is 2, this is 3. Okay? 2 plus 3 by 2. That is 2.5. Now we put it in the function and we are getting the value, this one. This value is negative. So since it is negative, this 2.5 will be updated in the negative place for the second iteration. So in the next iteration, where is the negative value? This is your negative value. So this 2.5 will be updated in the negative position and positive position will remain same. And again, this is your midpoint. And after that, we have find the functional value. Now here your functional value is positive. So where the positive value is present, that point will be updated. So positive value is present in the place 3. Here you can see this is positive value. So this point will be coming to the here and 2.5 this is remains same. Again, you have to find the midpoint of these two. So just plus and divide by 2, you will get the point, and after that find the functional value. And here again you can see it is your negative value. So negative value means this value will be updated in the negative position. So this is my negative position. So 2.65 goes here and your 2.5 is remain same. Now again find the midpoint and the functional value. Like this you continue, and here it says up to correct up to 3 decimal places. So now you can see here this 3, this 3. If you subtract this 3, what you will get? So if you subtract this 2.70605 minus 2.70654. So what you will get? 4, 5, 1, 5, 10, 5, 6, 0, 0, 0. So this is correct up to 3 decimal number, and this is your error. So this condition is satisfied. So your root is the midpoint of these two. So the root is your midpoint of these two, and this is this one. So I hope all of you have understand the process. Okay. So, okay, nice. So this is your, see, you can see this is your correct up to 3 decimal places. This thing is matching here. So that means we will stop here, and your root is correct, and your correct root is, hence the root is not this one. This is 2.706. Correct up to 3 decimal places. So that means after 3 decimal places, the number should be same. Whenever you are getting after 3 decimal, same number you are getting, that means you have to stop there. Okay. I hope all of you have understood it. Again, I am going to the next step, for the next example. Okay. So here also you can see sin x is equals to 1 by x. So that one we can write it x sin x is equals to 1. So that one we can write x sin x minus 1 is equals to 0. So this is my f of x. So I will assume it. Now I have checked f of 1 and f of 1.5. And I have seen that for the f of 1, I am getting the negative value, and it is I am getting the positive value. So my root lies between 1 and 1.5. So here you can see for the negative position, I have written 1. For the positive position, 1.5. Now what I will do, I have taken the midpoint of 1 and 1.5. So that is add this 2 number and divide it by 2. So I will get this. Now here what I am getting, whatever I am getting, that is my positive value. So this value will be updated in the positive position. So positive here. So that means 1.25 goes here, and your 1 will be remain same. Again, you have to find midpoint of these two, and you are getting the midpoint of these two is this, and again functional value that is also positive. So that means your positive value is here. So this value will be updated in the positive column. So this will be updated, and this value will be remain same. Now again find the midpoint, and again find the midpoint of these two. this is your midpoint and the functional value is this, and here it is negative value. So negative means this value will be updated in the negative position and the positive position will be remain same, again middle value. So like this, what is said here carried out to 7th step. So like see, I goes up to 7th step, and in the 7th step I am getting the root is this. So my root is this. So I will stop here. So I hope all of you have understood the bisection method, and here are the some practical example. Please try to solve this problem, and thank you for watching the video.